dozed off in the lab again. This happens sometimes. If you stay up too late the night before, you got to sleep or the next day if you're tired and you don't know what to do. And so I took a nap. I'm sorry. I forgot what we were. Oh! We were talking about cations and anions. I remember now. Oh, yes, hello. So, I am Professor Willett Boom. You, joining me here in my lab, you must know your way around because you came in my lab while I was asleep. That's kind of weird. I don't know if I like that. Please don't do that again. Don't sneak up on me when I'm asleep. I like to sleep. Okay, so we were talking about cations and anions and how they came from water, but when you take it apart, you make this, the cation, which is positive because it has the hydrogen, and then you have the anion, which is overall negative because although there's this sharing between the hydrogen and the oxygen, right? The hydrogen, they share the ionic bond with the electron. There's one missing, okay? One missing electron, so there's room for more, right? So if you put this in the presence of a water molecule which is intact, it can try to strip off a hydrogen, right, to get this filled, right? So that's what we can do. When we combine acids and bases, we could be combining acids and bases in a way that results in the creation of another water molecule. Boop, like that. See? Water molecule, when you put them together. When you take them apart, when you put it back together, you take them apart, and you put it back together, and then you just get rid of them, because you don't need them anymore, hopefully. So, okay, so we talked about all these, and if you remember, going back to the last episode, when you were here with me before, part 1 of part 2, part 2, part 1 of part 2, this is part 2 of part 2, okay, part 2. So we had the red cabbage, which you cut up, and we blended, and we strained it, with the filtration, with the coffee, we made the liquid, which tastes charming, cabbage water. So, this is a little bit of water with the cabbage blended, mixed, and pressed together to make the liquid, with your parents' permission, if you've acquired the necessary items, including Forky's safety goggles. They're not like patented brand name or anything, it's just what he's wearing. Those are Forky's goggles. You can't buy Forky's goggles. But maybe you could, I don't know. Maybe an offer, we'll see. So, we had the cabbage water ready to go, and what we're gonna do today is we're going to use this to test acids and bases, and we said that this could be used as a reagent or an indicator. And I might be using that word wrong. I have to look that up later. Reagent. I don't remember I'm using that word correctly. Sometimes I have words that come out, but it's not right in the right use. So we'll see on that one. I don't know. But it's an indicator in the reaction. Okay. So it allows you to see more what's going on, and it can tell you things. Like for instance, I put a little bit of this in a bowl, didn't need to be cleaned out, and I let it sit for, oh, I don't know, maybe 20 minutes, 30 minutes, something like that. And I don't know if you can see this lovely blue color. See this blue color in the water? The water here is from the pipes in the water, in the city water, and the water, it appears, is a little bit basic. And I say that because the color turned blue. Water is at least in my hometown, water is clear. Sometimes muddy or rust stained, depending on whose pipe it comes out of, at what house, but the water in the pipe is clear. You can clearly see that this water is no longer clear. It's blue. And it's because of the fact that it's slightly basic. Now remember, basic, see, and that, now I went and I threw away the ions, the cation and the anion. Oh, yeah, wait, I found one. Okay, so I found a cation. Okay, wait, and here I think I found, no, that's not it. Where did it go? Where did it go? Well, we have the cation anyway. So with the base, you have the O and the H. Oh, is it right in front of me? Oh, look at that. Will it go boom? No, will it go pop? There it is, pop. So we found the cation and the anion, right? So this is very careless of me to throw those away because I need them, right? So here we have the liquid here, which is the purple color, which is cabbage water. And so if I take a little bit of it and add it to the plain tap water, in this case, it turned blue. So I said there was a color range. Okay, so this is the said color range. Now, for those of you at home, hopefully this is very clear and easy to read and see. Okay, but we have the red cabbage, and so these are various liquids which have either acids or bases as a primary type or description. So the acid or the base has affected the color of the cabbage water. It starts off at purple, which is kind of in the center here, which is the number 7, which we said was neutral, right? And then as we go away from it, it gets to be an increasingly yellow color, right? The yellow mixed with the blue is where we get to green, but the yellow is at the extreme end. That's the hyperconcentrate base. Okay, so it has lots and lots of the anions present. The hydrogen oxide, hydrogen oxide. Yeah, hydroxide. So it has plenty of that, and that makes it yellow, and then it gets a little bit less, turns to green, then the blue, then the purple. When it gets to be in the middle, it's a neutral color, and then we get more acidic, it gets to be more and more red, and then kind of almost like a bright pink, I think, in magenta maybe. I don't know, fuchsia, magenta, one of those really lovely names. It could be a girl's name perhaps, or a boy's name, or a color's name, but it's a name. So this color over here, the pink, the fuchsia, whatever you want to call it, magenta, whatever. So those are the colors, right? So with those colors in mind, when I say that it is blue, the water from the city water, when it's sat with a little bit of cabbage, it is a base, and based on the coloration, it's not very strong, right? It's a little bit on the basic side, not very basic, which is okay, it's good. I'll tell you why. Because if you had a house full of copper pipes, and it was very bit acidic, it would eat away and erode it to copper, right? It's not good for the pipes. So if you were the city, it might be wise to try to convert the acidity level and bring it down to more of a basic, just below neutral, just below 7. So just above 7 technically, because the bases has a high range from 7 to 10, right? That end, right? So as we look at the bases, the higher it goes, it's off to 11, the higher it goes, the more basic it is. So this is fairly basic. So it's basically basic, just basically, basic. So we have that. All right, so now that we talked about the colors, you'll understand what happens when we do the science, okay? So now for the science. Now we have assembled here some household things. This is where you need the parent's permission. Not all chemicals can be combined safely. So I'm only combining chemicals for which I already have researched the combinations which are safe. Do not randomly combine chemicals from your home. Bad things can happen. We don't want you to have anything abnormal happen to you. I have here some safety information. Let's see where to go. Oh, there it is. I see it. Okay. Now, the reason I could find the safety information was because I have eyes on the back of my head. Yes, this is from not following safety precautions correctly. It's important to do safety right. Forky does science, Forky does safety. If you do science, you do safety too. Okay? All right, here we go. So we combine them. And we have, let's see, for later we'll do another. Okay, so we combine this with the household chemicals, which I've already tested in advance and I made sure are safe. So this is a little bit of pool cleaner for acid used around the pool. You can use to clean concrete and other things, but it's a little bit of pool cleaner. It's an acid called muriatic acid. And as I add a little bit of the cabbage water, just a little bit of the cabbage water, you'll notice that it is not staying purple, right? And the clear is not staying clear. Clearly you can see there's color change, okay? So what this tells me is, this is in fact a very strong acid. If you can see the degree to which the color has changed, and and it's so heavy, the acid, that the color is only penetrating down very slowly, okay? So, but if I were to take a cap, and remember, this one is acid. This is the strongest acid I had access to. It's very dangerous. Do not mess with it, okay? Even with the parent's permission, I do not recommend that anybody plays with muriatic acid. Nobody should be playing with muriatic acid, okay? This is science in a lab, okay? But you can see it's a very strong color, okay? Very powerful acid. So that's the acid there, okay? So we'll put that acid at one end over here, okay? Very strong. Now, let's see. I have something here. This is, I think, used in the cleaning of the plumbing. So I'm going to add this one very slowly. This is cabbage water also. But I want to see if you can maybe see this. Where's the color go? Is it turning to blue? Whoa, is it compressive, huh? Now if you watch it, that blue disappears. Where does it go? Where does it go? I ask you, where's the blue going? Well, there's so much power in this base, because it's a base, it's going from blue to yellow. So this, which is the drain cleaner, very dangerous. Again, I don't recommend that you at home try this with the drain cleaner. This is a very strong base, sodium hydroxide, I believe, but it's very strong, very, very strong, okay? Do not use this at home, okay? This are off limits in my opinion. Even with the parents' help, I do not recommend we use the strong acids or the strong bases. Please, I don't like to get those fan mails from the attorneys. I don't like it. Okay, so that being said, let's go to some other household chemicals. So this is one we use in the bathroom. We spray it on and we wait. It takes away the calcium. Okay, so this one is, again, one that's fun to go to the color. So we put it in there. And let's see. We're getting some pink. Okay, getting some pink. And, you know, depending on how much of this I add, sometimes the color can be more vibrant. But it goes from the green to a pink. Okay, not as dark. Okay, but remember, they were both pretty much clear when we started. So now if I add lots more, whoop, excuse me. Okay, so the color becomes more intense, but in this case, we also had the complicating factor of the green color. So it's a little bit hard to say for sure. Normally, I would say that these are gonna be right about in the range of these right here. Okay, so again, this is a cleaner used in the bathroom, not maybe as strong, but still pretty strong. So again, be careful. What you pull out from the cabinets could be very dangerous. Be careful, have a parent with you when you're doing it. Not just permission, a parent with you when you're doing it. And the safety goggles, okay? When the washing of the hands afterwards, lots of washing. Okay, so going on, let's see, what are the things we have around the house that are, I think, okay for you to mess with? Oh, here we go, here's two. So we have the baking soda, okay? And we have the vinegar, all right? So these are two, which I have provided here. Here we have baking powder. And I'm gonna go ahead and do this way, because it's gonna be quite a bit, I think, to get this stuff. Because it's a, well, okay, so it's dry, right? So it's a dry powder. So I'll get it a little bit wet to help start it, so that it's a little bit easier to see. And then as we put it up here, okay, more water. Again, I'm just trying to get it to be more of a liquid, because it's a solid when we start. Once we so like this, we'll go dropsy, 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 dropsy. Ooh, what a lovely color. Okay. And then we stir it, we shake it, we stir it, we shake it, we shake it, we stir it, we put the cap on, we shake it, the cap, and we shake the cap. Okay. And then we can see we have a nice blue. Okay, so on our tables, this goes somewhere towards the middle. Okay, towards the middle, kind of a blue. Okay. And we're getting back to you, okay? We know you want to know what you are, and ask for the base. Keep your pants on, okay? For crying out loud. Okay, so let's see what else we had. We had oh, hey, where's things we drink? Where's things we drink to test, right? So here we had, oh, it's a Coca-Cola. Coca-Cola. It's a Coca-Cola. I'm not sure how much it's gonna take to do this reaction, so let's see. Now, oh yes, quite red. Now for me, because of the way this lighting is set up in here, I can see the color change, and it went from a brown to a very red. Again, okay, remember what we said. Sometimes the colors of what we started with affect what we see, okay? But this is the Coca-Cola, and it is brown when we started, and now it is quite red. It is not that much different than what we use for cleaning the bathroom. When you take away the darkness because of the brown, that red is pretty red, okay? So that's telling me that Coca-Cola, they've used it for cleaning ship decks. They've used it for taking rust off of tools. It's a very strong acid in that Coca-Cola, so don't be fooled. Oh, here we got something else we drink. Oh, this appears to be the orange soda. I think we had a Fanta. And again, we started with something which already had a little bit of the color in it, but you can see the purple and the orange shouldn't really be making the pink, unless we're saying that we have some kind of acidic content, which apparently we do, right? So kind of acidic. So the things that we eat, right, are they good for us? Are they bad for us? It depends how much, how often, right? But when we start looking at it, most of the things we eat, they are either on one end or the other, not too many things in the middle. And we're going very long again. We are. But, you know, it's science. It is what it is, I guess. So here we have, this was the mango, pineapple, orange, I think. Maybe apple too. So again, kind of in the middle here. And then we have, this is, no, you know, that was Tang. Reminds me, I have to think about that one. That reminds me of something. I can't remember what. My calendar, something about Tang. Okay. Ooh, and this is a, I think this one was the one with the pineapple. Pineapple is a very, very acidic fruit. So that's the pineapple, and the orange juice. And then this one, I think this one was my ginger beer. I like ginger. It's a like root beer, but with ginger, which is a root. So it's still a root beer, but it's a ginger. But it's not fermented. So it's just something even the kids can try. It's something you can try. This particular ginger beer is Reed's is one that's in it, but I don't know. So I think that's what I had. So and this one, whoa. Okay, so that's interesting. So this is the first one we've had that stays very similar to the original color. I mean, it changed a little bit. It's still somewhat of acidic, but you can see it's closer to the purple. So this is kind of the closest we've gotten to the middle, right? So now we're kind of creating our own, right? Let's see. Oh, this is these are the ones that clean the teeth. If you have the teeth that the fake, you can add these tablets, and they do the fizzy stuff. Whoa, whoa, that's pretty impressive there. Let's add a little bit of water to help to speed things up here. What's a fizzing? I think it's a fizzing thingy. So let's see. We have a thing for mixing it, but I don't know what it is. It's a mixer. So there's definitely some blue coloration now. You can see that. See, there's a blue, a little bit of blue. Yeah. So that's telling me that there's, and that, whoop, will it go boom? Perhaps. That's why the cap's on there. Maybe that's why the professor left the cap on, was to keep it from doing that. There's a smart guy, that guy, the professor guy. So he had the cap on there, but I took it off. So you can see that they use the base for cleaning off the things that are on the teeth. Now it makes sense if you think about it, because we have so many foods that are acidic, right? And the base going in there would help to clean off the things that the acids aren't taking off the teeth. So as you go, that makes sense, right? Okay, so let's see what else we got going on here. I think that's all the things that we're going to test. So now as a final question, okay, we're going to show what happens when we test our dear friends, our dear laboratory assistants. When we test them, what are they? This is the part where you will be able to go back and to report to the science teacher, Miss Eccles, if she is a science teacher, which I hope she is, because she's very nice. She's a very good science teacher. I like that. The teaching of the science. It's important to me. My family likes science. We do science a lot. We do science when it's, bedtime sometimes, so we don't want to go to bed yet, but we like to do science. Science is king, like saying. They say. Okay, science is king. All right, so here, we'll take the extractor. Sorry, guys, but you asked for it, so here we go. Take the extractor. Oh boy, it's kind of stiff. Oh, yeah, okay, got it. Whew, okay. Don't worry, you'll only be like a quart low. It's fine. Okay. So we're going to test. This is this is assistant B. I think I said B earlier. This is assistant B with the green. And let's see what happens when we get his gray matter. Okay, clearly we have gray matter there. Okay, all right, good. Very good. Okay. Stay. Okay, so this is assistant B. Okay, and let's see, I'm gonna take these guys out. Whoop. That one's looking to make me some trouble later. Okay, put him over here. Okay, that's the way. Okay, so we have assistant over here, assistant B. Once then we're gonna have assistant A. Let's go ahead and just I think it's getting through the leaky thingy. But okay, so we have assistant A and assistant B, assistant A over here. Okay, there we go. I got it. Whoops, it is easy, as they say. Okay, a little bit. There we go. Thank you, assistant. Okay. Okay, so we have assistant A, assistant B. So now, if we wanted to test the assistant, okay, we could take and we could add the reagent, right? Or the indicator. I keep calling reagent, I don't know. That word's stuck in my head. So we can add some to assistant A. A little bit easier for you to see, perhaps. So assistant A. Oh. Sometimes the professor, he gets caught before the apples, Okay, so assistant A, we're out of time, so I really don't have to do much analysis here. I don't have any time for that. But, you at home, you'll be able to do the analysis yourself. So let's see, assistant B. Okay, so assistant B here. Oops. Okay. Oh, go on now. Just had it open the other side. There we go. Sorry. It's like lefty, loosey, righty, 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 tighty. All righty. So here we have assistant A and assistant B. When they want to know the type, so they could put it into the information on the app, the chemistry app, right? So, okay, all right, there we go. All right, so now we have assistant A, okay? And you are going to draw your own conclusions, and you're going to share them with Miss Eccles. Now, please don't share your observations with others. Okay, share them with the teacher, and I want you to tell me based on what we're seeing here. What can you tell me? There should be probably, I don't know, but maybe 3 different things you could tell me about these based on these indications, these results. Okay, so I remind you again, we are here talking about how water, right, made up of cations and anions that have been joined due to the covalent, I think it's covalent bonding, sharing, whatever it is. Here we have 2 hydrogens, H2O, right, split apart, make the cation and the anion. We learned about the basics of basics. And, you know, that's about all the time we have. But there's something on my calendar for today, and it just said Tang. Now that is most peculiar. I really believe that might be my space hatch. Hello? Oh!
Hi.
Hello! Hello! Oh, you just drifted in. Where are you from? How are you doing?
Space.
You come from?
I got your space balloon.
A space balloon, how lovely. And what is this?
Thing.
Tang, the official space drink of the National Aerospace Association, NASA. They like the orange. They like the Tang, right? The Tang is the orange. They like the jumpsuits, which are orange, right? And orange, you're gonna ask me something?
I'm not orange. I have. Oh, I forgot. I have.
You're a spaceman with no boots? You know, I know.
forgot them.
Let's go. I think I know some place we can find boots and pants and boots and pants and boots and pants and boots and pants and.